From the outset, the Space Force encountered critics. Air Force officials questioned its necessity. And some political observers feared it marked the onset of a costly and perilous militarization of another domain. However, it was challenging to dispute how nearly every facet of modern warfare, defense, intelligence, surveillance, communications, and missile detection has become reliant on connections to orbiting satellites. Enter a high-tech space explorer. The Boeing X-37, affectionately known as the Orbital Test Vehicle (OTV). This sleek robotic spacecraft receives a boost into space from a reliable launch vehicle. And the fascinating part is that after its space adventures, it doesn't simply fade away. No, the X-37 re-enters Earth's atmosphere with flair and lands like a boss, playing the role of a spaceplane. This Space Maverick isn't on a solo mission, it's part of a dynamic duo with the Department of the Air Force Rapid Capabilities Office leading the way and collaborating with the United States Space Force. Their goal? To showcase some nifty reusable space technologies through orbital spaceflight missions. The X-37 is like a larger, bolder cousin of the earlier Boeing X-40, scaled up by a whopping 120%. Its journey began as a NASA dream in 1999 before transferring to the United States Department of Defense in 2004. The Air Force Space Command initially spearheaded the operation until 2019. Now, let's delve into its cosmic journey. The X-37 had its inaugural flight during a drop test in 2006, showcasing its skills. Its grand entrance to orbital missions occurred in April 2010, hitching a ride on an Atlas V rocket. Fast forward to its fifth mission, lasting a remarkable 780 days in orbit, a record breaker launched on a Falcon 9 rocket. The latest space escapade, the sixth mission, took off in May 2020 and concluded in November 2022, totaling an impressive 98 days in orbit. Hold on to your astronaut helmets because the adventure doesn't stop there. Mission 7 is already geared up for liftoff on December 10, 2023, riding the powerful Falcon Heavy rocket. In the late 90s, NASA turned to Boeing Integrated Defense Systems to bring its grand vision for an orbital vehicle to life. Over 4 years, the California branch of Boeing's Phantom Works poured a cool $192 million into the project. With additional contributions from NASA and the U.S. Air Force. In 2002, NASA awarded Boeing an even larger contract of $31 million as part of the Space Launch Initiative framework. The X-37 isn't just another spacecraft, it exudes style, inspired by the larger Space Shuttle orbiter. Think of it as a cosmic cousin sharing a similar aerodynamic design, allowing it to slice through the cosmos with a lift-to-drag ratio reminiscent of the Space Shuttle legacy. However, its cross-range at higher altitudes and Mach numbers is a bit lower compared to DARPA's hypersonic technology vehicle. Originally envisioned as a cosmic handyman, capable of rendezvousing with satellites and performing repairs, the X-37 was slated to hitch a ride on the Space Shuttle. Plans shifted due to the high cost of a shuttle flight, leading to a redesign for a launch on a Delta IV or a similar rocket in 2004. The X-37 took a detour from NASA to the Defense Advanced Research Projects Agency in 2004, turning the project into a classified mission. DARPA portrayed it as part of a space strategy post the 1986 Challenger disaster, adding an air of mystery to this interstellar tale. In its early days, the X-37 was more like a glider testing the Earth's atmosphere. Picture a simple gliding vibe with no fancy propulsion system, just pure gliding. Instead of payload bay doors like its spacebound siblings, it sported a sturdy upper structure, ready for a cozy connection with its mothership. The X-37 underwent atmospheric drop test, with the launch plan featuring the scaled composites White Knight, a high-flying research aircraft. The X-37A finally tasted the sweet freedom of a glide flight on April 7, 2006, after overcoming some adventurous moments during landing, such as overshooting the runway. After repairs, it shifted its base from Mojave to Air Force Plant 42 in Palmdale, California, to continue its flight test program. The X-37B orbital test vehicle emerged when the U.S. Air Force decided to spin its own version of NASA's X-37A. Boeing took center stage as the chief architect of the OTV program. The X-37B wasn't an ordinary space traveler. It was designed to be a space sentinel, capable of camping out in orbit for an impressive 270 days at a stretch. Most of the X-37B's exploits are shrouded in secrecy, with the Air Force calling it an experimental test program to flex technologies for a reliable, reusable, uncrewed space test platform. Its goals include testing avionics, flight systems, guidance and navigation, thermal protection, insulation, propulsion, and re-entry systems. The X-37 orbital test vehicle is a nifty, reusable robotic spaceplane, a sleek, scaled-up cousin of the Boeing X-40. Stretching over 29 feet and flaunting two cool tail fins, it hops onto an Atlas V or a SpaceX Falcon 9 or Falcon Heavy rocket when it's time for liftoff. The X-37 is more than just a preface, it's a playground for cutting-edge technologies. Check out its improved thermal protection system, fancy avionics, autonomous guidance system, and a futuristic airframe, paving the way for next-gen space travel. Speaking of thermal protection, the X-37 rocks a system built on the shoulders of previous atmospheric re-entry spacecraft, with snazzy silica ceramic tiles keeping it cool. Its avionics suite played a role in the development of Boeing's CST-100 crewed spacecraft, showcasing its influence. The X-37 was born not just for glory but to lend a helping hand. NASA had big dreams for it, hoping it would assist in designing the orbital spaceplane for crew rescue and transport to and from the International Space Station. Now, let's talk engines. Originally, NASA's X-37 was set to be powered by an Aerojet Arkansas 23 engine, a trusty workhorse with storable propellants. However, the engine lineup reportedly shifted to a hypergolic hydrazine system, giving the X-37 an engine makeover for its journey. When it's time to wrap up the interstellar adventure, the X-37 doesn't need a pilot. It's equipped with automatic landing skills. This makes it the third in line, following the Soviet Buran shuttle. And the US Space Shuttle, to pull off this cool trick. A tidbit worth noting is that it's the smallest and lightest orbital spaceplane to grace the cosmos. Weighing around 11,000 pounds and only a quarter of the size of the iconic Space Shuttle orbiter. To top it all off, the X-37 bagged the 2015 Space Achievement Award from the Space Foundation. Recognizing its stellar role in advancing reusable spacecraft and on-orbit operations during its space escapades. Totaling an impressive 1,367 days.